Welcome to Investigation 3.2, where we are going to investigate salt solutions. So, today, before we start, I wanted to ask you, what are the parts of a system we call a solution? What are the parts of a system we call a solution? Dexter. A solvent and a solute, right? Perfect. How do you increase the concentration of a solution?
By adding more of the solute?
Yes. Perfect. So by adding more powder, by adding more solute, right? And then if we're adding more solute, what's another way we could do it? What's another way? Dexter knows. Azmi?
Mixture?
No, you didn't understand.
Solvent?
Yes, add more solvent. You increase the solvent, right?
Which makes it concentrate.
Or yeah.
No, but wouldn't that make people dilute? That would make it dilute.
No, sorry. Less water, less solvent. Yes. Sorry about that. Less solvent. So add less solvent, right? Or more solute. Yes? All right. So
yes.
How do you decrease the concentration of a solution?
Solvent.
But do I increase it or decrease it? Remember, I'm decreasing the concentration.
Oh.
Kennedy.
Solute?
Yes, but I'm looking for a little bit more. Azame. What's that?
Dilute?
Okay. Texture.
You can either decrease the solute or increase the solvent.
Right. Either decrease the solute or increase the solvent, right? That's how we change the concentration. We decrease the concentration. What is the term when we use when something is a less concentrated solution? Dilute. All right. What evidence tells you of two soft drink solutions is more concentrated? How do you know if one is more concentrated? Daniel.
By adding more.
No. How do you know? What's the evidence?
By the taste and the looks of it. Sometimes it can be darker than the other.
Yes.
Like we did with the juice.
Exactly. All right. So today we are going to investigate the concentration of salt solutions. There's a problem. Well, not really a problem, but you are not permitted to taste. Okay? All right. So we need to look for other ways to collect data, right? All right. So how can you determine which salt solution is more concentrated? So we're going to use a couple of different tools to help us, because we can't taste it, but we can still use our eyes. Not going to use our nose, and we're not going to use our mouth. So we're going to use our eyes, and we're also going to use our balance, and we're going to use some mass grams, and here's a graduated cylinder. Graduated cylinder is going to measure volume, and the balance is going to measure mass. Yes.
Can't you do it by because if it overruns the liquid, there would be no salt particles that don't dissolve, so you can just feel the particles.
Possibly, but I think it might all dissolve. Okay, so I have cup 1, cup 2. Yes?
Mm-hmm.
All right. So what I'm going to do is put in.
We have the cups out.
I'm going to take. First, I'm going to write on the board. Solution 1. Solution 2. All right. I'm going to use a 5 milligram scoop. I'm going to put 1 5 milliliter scoop of salt into solution 1. Then on solution 2, I'm going to put 3 5 milliliter of salt.
That's 15 milliliters.
Okay. So let me start with that. All right. So we have our salt. Next, I'm going to put 50 milliliters of water in each one. So it's going to be the same. So I'm going to make sure I don't have any air bubbles. Oh, I got an air bubble. Okay. Okay. And the reason why we don't want air bubbles is for accuracy. Okay. I do the same thing with, I got an air bubble again. All right. All right, so now each solution, don't rock. I'm going to mix each solution so that the salt dissolves into the solution. I'm going to try to mix it up as well as I can. What do you notice? What do you notice, Evie?
Number 1, more see-through.
It's more, what's our word?
Transparent.
Transparent. Solution 1 is much more transparent. Solution 2 is what? What do you want to say, Kennedy? Say it again. Say it. I can't hear you. I still can't hear you.
Concentrated.
Concentrated? Oh, okay. Maybe more concentrated. Dexter?
It's like cloudier and
It's cloudier, definitely. Azame?
it's like a milky.
It looks a little bit milky.
Barely.
Vic?
It looks like different color. Like it looks like a cloudy kind of color.
Okay.
But like the normal one's more transparent.
Uh-huh. Okay. All right. Thank you. Great minds think alike. Jaylene earlier this morning said she thought solution 2 looked colder because as it was dissolving, it started looking cloudy, and she thought, gosh, it looks colder. And she said just because the cloudiness made it seem colder to her. Okay, so let me write this down now. Now I added 50 milliliters of water and 50 milliliters of water, right? Yes. All right, so just because remember, as scientists, you're always taking notes, you're always writing down what you're doing, correct?
Yeah.
Now, why do we do that again? Can you please put that on the floor?
So we can redo it if like something happens.
Because
You take the same step.
yes, so someone else could take the same steps. All right, so now we are going to now think about this. Which of these two solutions would have a greater mass? What do you think, Esme?
I think solution 2.
Why do you think solution 2 would have a greater mass?
Because it has more salt.
Interesting, because it has more salt. Evie.
And like with our previous experiments, like when we did the way with the water and then the water for the salt.
Yeah.
The added salt made it way more.
Exactly. I was wondering if you would remember that investigation that we did. Claire.
The mass does not change weight no matter what state of matter or volume it is in, because it's still, matter cannot be completely destroyed, so it's technically still there.
Yes. Okay, so the matter did not go anywhere, right? We added it, but it still exists inside the liquid, right? Now, remember what we did before. So if you added the 5 milliliters of salt and the 50 milliliters of water, what do you think it could weigh? If we put these together, what do you think, Dexter?
Well, due to our previous experiments, we learned that a milliliter usually equals a gram. So if you add those together, you can get 55 grams.
Yeah. So we've learned by everything that we've been doing so far, using the weight table, the grams, using the balance, and just some of the other observations we've made, and what we've learned about concentration, right, and density, is 5 milligrams of salt plus 50 milligrams of water is going to end up weighing 55 grams total, right? Okay, so over here, what should we change 5 milliliters salt to?
15.
Let's change it to 15. So, how much will 15 milliliters plus 50 milliliters, 15 milliliters of salt, 50 milliliters of water?
Okay, what about
How much should that weigh, Vic?
65?
Should weigh 65 grams, right?
Yeah.
Okay. So this is weighing the mass. So based on what we already know, this is what we're predicting, correct? Yes or no?
Yes.
Okay. So before we go any further, I'm going to pass out a page that looks like this. It's called Salt Solutions 1 and 2. I'm going to pass this out. You're going to glue it in, and you're going to write down, start off by writing down, like what we did yesterday, the similarities in just what you can see. Okay? Then we're going to go on and we're going to discuss the differences, but we can't do that quite yet. So let's go ahead. I'm going to pass this out. And you're going to glue it in and get started. All right, so now that you have your paper, you're going to record the similarities in our two solutions. Then we'll go through and discuss the differences. Okay, so now everyone wrote down the similarities, and I thought it was quite impressive that you guys picked out. They both have salt in them. They both have water in them. They're both transparent. They're both a solution. They both have a solvent. They both have a solute and a solvent in it. And in both of them, the salt dissolved. Well done. And they're both a mixture and a solution, right? Nicely done. All right, so now what we're going to do, because our focus question is how can you determine which salt solution is more concentrated? How can you determine that a salt solution is more concentrated? That's our focus question, especially as we start manipulating what's in the solution. Okay? All right, so we're going to start with number 1, and we're going to check our math. Okay, so I'm going to put 1 in. I'm going to use an empty cup. I'm going to use our mass grams. All right, so I'm going to start with 120 gram. Nothing really happened. I'm going to use, here's 20, 30, here's 40. Now I'm going on to the 5s, 45, 50. $55. Did it? Here, let me move it a little. So it's more balanced. How did we do?
Good.
Was our math correct? Was what we
Yeah.
already thought? Were we spot on?
Yes.
Okay, good job. All right, so now I'm going to take our gram pieces out. I'm going to switch our solution. I'm going to mix it one more time. All right, here we go. Here's 20. Here's 30. Here's 40. Here's 45. Here's 50. Here's 55. Here's 60. What did we say? 65?
Yep.
65.
Yeah, we're spot on.
We did it again.
Yeah, that's exactly 65.
Based on what we already knew, we were able to say we predict the mass, what the mass is by putting the salt and the water together, right? Okay. Just because it dissolved doesn't mean it went anywhere, right? That's our big idea here.
Yeah.
Okay, so now let's take a look. Now, I want to discuss really quickly a word. It's called variability.
Oh,
Hold on. Now, if I had sectioned you off into groups and I had given you solution 1 and 2, you created it, each group created it, took it, measured it, we might end up having a chart that looks like solution 1, solution 2. We'd have mass, volume, and we might have, if I asked each group to share with us their results, we might have some groups that measured 51, 52, 50, 55, 52, 51, right? Now, because I asked different groups to do it, there might be a variability in there. The answers might have varied. So I just want to remind you of that word, variability, okay? And that means like taking a sample from a group and then coming together and going back and trying to figure out the true amount. Yes?
Yes.
Okay. So I just want to make sure you understood that word and know what that means. And it helps with repeated attempts, right? To get something more accurate. All right. So do the two solutions have the same mass?
No.
No. Okay. So now let's go to volume. This graduated cylinder is going to measure becoming 1. They are going to All right, this comes to about 52 milliliters. It now is measuring. So what did what happened to the water?
It changed form.
Okay, yes, it changed to the form it was poured in, yes.
Got higher.
It went higher, so it measured what?
Measure the salt.
It measured its height, so it measured what?
The salt too.
More, right? It increased its volume, right? Okay, so its volume, let's come over here and write 52 milliliters for volume. Okay? Yes, Asmai?
Isn't it kind of like ice when you put like ice in a drink, it makes it go up?
Yeah. But this is completely dissolved. But it's showing us it still really is there, right? Because it actually increased its volume. Yes? Okay, so now let's take solution 2. Let's measure. Oh. It's a little bit higher than 50. Okay. Let me pour some more into the other graduated cylinder. So this measured 50 plus 6, let's say 6, 56. So it started at 50, right? Now it's about 56 milliliters for volume. Yes? Okay, so now on your paper, it has similarities and differences. So now we're going to talk, what you're going to do right now is record the differences in the two solutions. Go. Okay, I'm going on to solution 3. I'm going to now take 3. Let me make sure I have my recipe correct. Okay. I'm going to take 3 milliliters of salt. 5 milliliters of salt. And I'm going to mix it with 150 milliliters of water. Okay. Now, back to water. So now I have to fill this up. How many times do I have to fill this up? If I'm now going to do 150.
Twice.
3.
And this is only worth 50.
Oh, yeah.
So how many times?
3.
3 times. Okay, so now,
Where'd you get that syringe from?
kit,
6 things that you get at
a medical lab.
Does this group say you everything?
Yes. Well, almost everything. Okay. All right. So now we have a solution
Not new equipment, no.
with 15 milliliters of salt and 150 milliliters of water. My question to you now is, which solution is more concentrated? 1, 2. Where did 2 go? Oh, here's 2.
You like know how much salt is in each one.
Yeah.
That's all we need to know.
2 or 3? What do you think? Vic?
I think 3.
You think 3. Okay, Cooper, what do you think? Pick a number.
3.
Okay. Kennedy.
3.
Dexter.
2.
Okay.
2.
2.
3. 2.
Okay. All right. Oh, Daniel, what do you think?
2 because of
Zadie. Okay. Azame.
2.
And David. Okay. Angela, what? 2. Okay. Okay, so now this has 50 milliliters of water. It started with 50 milliliters of water. It started with 50 milliliters of water. I'm now going to pull 50 milliliters of water from 3. So this is a solution, this is a solution, and this is also a solution, right? All right, let's go ahead and measure the density or the concentration of 2 and 3.
Oh wow.
Which is heavier?
2.
2 is heavier. Okay.
So now 2 is winning so far.
Okay, so now, whoops, 3 and 1. Oh yeah, we'll measure the volume as well.
Oh, it's gonna be. It's 1. It's 1.
What did we discover?
It's the same as 1.
They're actually 1 and 3 are actually balanced. Now watch.
I know.
Because I'm going to tie this to something that you guys have been learning about. Fractions. Okay, solution 3, 15 milligrams of salt. And we did 150 milliliters of water. And if we were to weigh it, what do we predict it's going to weigh?
We predict it's going to weigh 165.
165 grams, right, for mass? Okay, now watch. 5 out of 50. What is 5 out of, how do you reduce or simplify 5 out of 50? Kaden.
And I know what it is.
Okay,
I just
Evie.
can't think of it right now.
1/10.
Yeah.
Okay, then what is, here is 15 out of 50. What's the fraction, simplified fraction going to be?
I know.
What is it?
3
3/10. Then, what is the simplified fraction? Dexter. 1/10. Okay, so the solution is 1/10, is 1 to 10, right? The solution is 3 to 10. And the solution is 1 to 10.
So it is 2.
So 2 is definitely the heaviest, or so if it's the heaviest, it's also what? The most concentrated, right? Okay, so what I want you to do at the bottom of your page, I want you to write down, can you answer the focus question? How can you determine which salt solution is more concentrated?
By using fractions.
So how can you determine? Okay. All right. So we will come back and we will measure the volume in both. And then I have one more page that we're going to finish up tomorrow to wrap this up before we start 3.3.
It says
This one we're going to do next, comparing salt solutions. Okay, this one is quite easy. So that'll do it for today. Have a great day.
Bye.